Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue with lecture 8 and part 2 of designing IoT system. In this second part of designing IoT system, we're going to look into modern communication protocols, wireless communication technologies, proximity network communication protocol, and also gateways. Let us go to modern communication protocol first. Modern communication protocol, Ethernet is very important. What is Ethernet? Ethernet is a system for connecting the number of computer systems to form a local area network, which is the LAN, with protocol to control the passing of information and also to avoid simultaneous transmission by two or more systems. There are two types of Ethernet. Okay, so the first one is standard Ethernet. Standard Ethernet is the network technology which already being used in commercial and enterprise everywhere. Okay, so Ethernet is a protocol as well as a technology. It's transport over copper wire. Okay, so if you see the LAN cable that we use usually, okay, so there are two type, Cat5 and Cat6 cable. Okay, so this is usually used, and currently people also using the optical fiber, okay, and also radio wave, for example Wi-Fi and microwave, in short, middle and long range deployment. Okay, so in order for us to be connected to the internet, Ethernet is popular because back in early 90s, it became dominant networking technology in the growing commercial computer networking business because it is very easy to be installed. Okay, so for the user to use it, you just plug in the Cat5 or Cat6 level cable to the computer. You will be able to connect to the internet. Okay. Ethernet also cheap and easy for network designer to plan network topologies and for technician to deploy and troubleshoot. Okay, consequently, the Ethernet become the well-established network technology in the enterprise and also in the industry and also in the building, and everywhere is using it. Okay. Okay, so the second type of Ethernet is industrial Ethernet. Industrial Ethernet is not much different from the Ethernet we use in the business, in the building, and everywhere else. Only that they use the same frame and protocol, but the difference will be the cabling, the connectors, and everything is much more robust. Because of course we are going to connect a lot of devices, a lot of computers together in one factory or in one places of the industry. Okay, industrial Ethernet is 100% interoperable with standard Ethernet, meaning that it can be a combination. For example, if you already installed the standard Ethernet, it can be upgraded into the industrial Ethernet. Okay, so even if you are one part of the industry is using standard Ethernet and another one is using the industrial Ethernet, it still can be what we call interoperable together, okay, at the same time. Okay, industrial Ethernet use robust cabling as it must typically endure harsh environment, because if you look into the factory or into the certain area of the industry, there might be high humidity, high heat, or it can be high in pressure or something else. Okay, so that some of places also might have a very high vibration. Okay, and there are also interference in the environment. Okay, so that's why industrial Ethernet, it has to use a much more robust cabling and connector. Yeah, I put link here so you can read much further about the industrial and standard Ethernet. Okay, so if Ethernet is more into something connected, internet that became connected using the cables. Okay, so now we go for the wireless communication technologies. What we already see in the previous lecture. Okay, so wireless communication technology is very important in the Internet of Things. It is one of the what we call technology that make the Internet of Things possible. The problem was that there was no way to connect the sleek microprocessor controller to the sensors and actuator without running wires throughout the factory. Okay, so this is the problem previously we have to face when we're using the Ethernet only. Okay, so then they come out with the technology such as Wi-Fi, Bluetooth, and Zigbee. Has removed this barrier. Okay, so by having the connection wirelessly, they make the Internet of Things possible, because you don't have to connect a lot of wires in the industry. Okay, so however, there are also some recurring themes. There are not one wireless standard that fit all purpose. Okay, so although uh, we know that this technology is used widely, but we don't know, we have to know what type of wireless that suitable with our what we call our factory or our industry. Okay, so the array of wireless technology has arisen because they serve different purposes. Now, let us recall back the wireless technologies that we already see previously, which are Wi-Fi, Bluetooth, and also Zigbee. Okay, so Wi-Fi usually designed for high bandwidth and throughput for web browsing, for downloading from the internet. Okay, and then for Bluetooth, usually it's designed to provide a personal area network so that we can connect to the wireless and the device that you want to wear or you want to carry, so it can be mobile. Okay, so for example, the mobile phone, watch, headset, you can move freely while using the internet by connecting through this Bluetooth. Okay, Bluetooth range and also capabilities also improve beyond the scope of the PAN a little bit. Okay, so they increase the area, the range between the what we call for the connection to happen. And then we have Zigbee. The capabilities is fell between Wi-Fi and also the Bluetooth. Okay, so meaning that it's in the middle. Okay, and then at least that's how it started. Okay, so how nowadays Zigbee covers neighboring area network or NAN also in industrial IoT scenario. So we will see how they upgraded from the normal Zigbee into something bit better. Okay, uh, as we see, regardless of the technologies that we choose to adopt, it will always have constraints. For example, the range, throughput, power, physical size, and cost. Therefore, when we want to apply these technologies into our industry or into our system, we have to be very diligent in terms of the approach in the evaluating the wireless technologies that best suited to our need. As we know, the Wi-Fi that we use usually is quite heavy. Okay, so which is sometimes it is not suitable for the IoT upgrade in terms of this technologies is done in order to make sure that it can be what we call it can be applied in the IoT. Okay, so the IEEE upgraded the Wi-Fi into the IEEE 802.15.4, which is a technical standard which define the operation of low rate wireless personal area network. Okay, so they make it into a low rate wireless personal area network, or LRW part. Okay, so it was first back in 2003 where they set the standard for low power commercial radios. Okay, so this one is to make sure that if the device with low power connected to this Wi-Fi connection, it can be used. Okay, so it will not consume too much power. Okay, so the standard was upgraded in 2006 and then 2011, so that it can provide a more energy efficient radio technology. Okay, so to the devices. IEEE 802.15.4 is the basis for the Zigbee ISA 100.11a wireless HART and MIWI specification. And then it further extend the standard by developing the upper layer which not defined in IEEE 802.15.4. Okay, so it might you might what we call not familiar with all the terms here, but it's okay for you to know. This one is just to inform you how the Wi-Fi have been upgraded from the normal Wi-Fi into something that a much more applicable to the IoT. Okay, so this new Wi-Fi can be used for the low 6 low WPAN, which is for the connection for the low rate wireless personal area and standard internet protocol in order to build a wireless embedded internet. Okay. Now we look into the improvement in terms of the Bluetooth low energy. Okay, so previously it's just the normal Bluetooth, but as we know in the IoT, we need to use a lot of low energy devices. Okay, so they upgraded it into Bluetooth low energy, which also known as Bluetooth 4.0 or Bluetooth Smart. Okay, so this is the version of the Bluetooth technology specifically designed for the IoT. Okay, so as its name suggests, this is a power and resource friendly version of the technology. The purpose of the design is to run on low power devices that typically run for low periods, either harvesting energy or powered from a coin-sized battery. Okay, so meaning that it is used for the low energy devices, and even this particular what we call devices can harvest the energy so that it can power the coin-sized battery so that it can continuously be used. Okay. The advantage for the Bluetooth low energy, we know that Bluetooth has already been around for decades, so there are billions of Bluetooth enabled devices, only it is upgraded into low energy. Okay, so then there are a lot of devices that can be connected to this system. It is already a well-established and recognized standard wireless protocol. There are a lot of vendors that are supporting and also interoperable to this system, which make it an ideal technology for the developer. It is low peak, average, and idle power. So that it will allow device to run on low power sources, make it ideal for low power and devices. Such as the WSN nodes. Okay, so if you remember what are the WSN nodes, and for example, in the IoT and also the M2M edge network. Okay, so in the factory, for example, the sensors and everything they already installed in the factory or in the industry. Okay, so the next one is Bluetooth work over a short range and Bluetooth enabled device pair with one another in a master-slave relationship so that it can be in order to communicate. So what is master and slave relationship? If I can give you the example, so if you have that Bluetooth connected with your computer, you can connect and when your devices that already set can be connected to that Bluetooth, whenever it goes into that range, you can directly connect to that master which is your PC, for example. Okay, your laptop or your PC, where you can connect your headphone, you can connect your handphone, you can connect other devices that your printer or anything that within that range of the Bluetooth. Okay, so that is what we call as master and slave relationship. However, what makes the Bluetooth suitable for the WSN node is the ability for ad hoc network. Or ad hoc network meaning that whenever you go into that area, it can be connected directly. Okay, so this is what we call as Piconets. Okay, so if you can see in the picture, so let's say the blue one is the master. Whenever one devices enter the area of this Bluetooth connection, okay, it will directly connected to the master. Okay, so let's say this is second one going into the area, and then it will connect it together. For Piconets, you can connect two devices, or the maximum up to 8 devices together to the master. Okay, so this one will make the system much more efficient. Okay, so because you can connect a lot of devices into that one particular master. Okay, um the Piconet consists of 2 or 8 devices that communicate over short distance, like you see that like I mentioned previously. Additionally, Bluetooth ubiquity miniature format, low cost and easy to use, make it a very attractive short range wireless technology. Okay. Now let us look into the last one, which is Zigbee and Zigbee IP. Okay, so previously we only know that Zigbee. So Zigbee usually used in the houses so that you can use it for smart home or smart building or something like that. Now, they upgraded the Zigbee into Zigbee IP, which is an open global wireless technology and specifically designed for use in consumer, commercial, and industrial area. Okay, so therefore, Zigbee is low power and easy to use, and is universal among IoT network sensing, so and control application and devices. Okay, so meaning that the coverage will be bigger compared to the previous Zigbee, which only used in the what we call consumer and also commercial one. Currently, when it upgraded to Zigbee IP, it become possible to be used for the industrial area. However, what makes Zigbee different is that it is a supernet of IEEE 802.15.4 in so much as it provides application and security layer support. Okay, so like we already see previously. This enable interoperability with product from different manufacturer. Okay, so because of this support from the IEEE 802.15.4, you can what we call operate the devices and connect it together, although it is from different manufacturers. For example, device one is from another manufacturer, this one is from another manufacturer. It can be operated together for the industry. Okay. The original Zigbee also have a problem where it did not support IP, which is problematic when it come when you want to interface the Zigbee network with the real world. Okay, so because IP is already being used everywhere, right? Because it comes first through the Ethernet. Okay, so when Zigbee come into the picture, of course it is make the life easier for people and everything. But if we want to integrate together the Zigbee and also the IP system, they need to be compatible to each other. So they upgrade the Zigbee into Zigbee IP so that it can be connected together. However, the Zigbee IP specification is built with a layer architecture and is therefore suitable for any link layer within 802.15.4 family. Zigbee IP takes advantage of this layer approach and incorporate technologies, for example, 6-low WPAN and RPL that optimize meshing and IP routing for wireless sensor network. So meaning that they utilize this IEEE 802.15.4 to make sure that Zigbee can be connected with the IP system, so that more devices or sensors can be connected through this system. Okay, so it make the Zigbee compatible with the IP system. Now we look into the proximity network communication protocol. And we want to consider the communication protocol for the proximity and access network. We have to consider diversity and capability of the existing devices and also the communication lower layer protocol. As we learned previously, not all protocols support IP, so you have to consider this protocol when attempting to find the common data and network layer protocol. Okay, so let us look into what is IP. Okay, Now let us look the first Internet Protocol, which is IPv4. Okay, so the IPv4 address is a 32-bit number that uniquely identify network interface on a machine. So IPv4 address is typically written in decimal digits, formatted as 4-bit fields that are separated by periods. Okay, so we're going to see the address later. Okay, so each 8-bit field represent a byte of the IPv4 address. So IPv4 use 32-bit addresses, which limit the address space to around 4.29 billion addresses. Okay, so if we IPv4 reserve special address block for private network is around 18 million, and multicast address around 270 million address. Okay. Let's see the private network and multicast network in the IPv4. Okay, so for private network, it's usually used for the computer network that use private address space of IP address. So you know that each computer will have their own address, right, for internet connection. Okay, so using the IP number. Okay, so this address are locally used for local area network in residential, office, and enterprise environment. This is what are the IP before for us, for the common user use every day. Okay, so for multicast network is a group communication where data transmission is addressed to a group of destination computers simultaneously. So this one is usually for much bigger what we call setup of computers. Okay, multicast can be one to many or many to many distribution. Multicast should not be confused with physical layer point to point to multi-point communication, and multicast is often employed in internet protocol application of streaming media, for example the IPTV and multi-point video conferencing. So let's see the address for IPv4. I believe many of you have seen in your own laptop or in your computer, there are 4 numbers that separated by the dot. Okay, so for example here, 129.144.50.56. Okay, so this the first 2 number is the network part, and the second one is the host part. Okay, so the network part specify the unique number that is assigned to your networks. Okay, and then the network part also identify the class of network that is assigned, and in above the network part occupy 2 bytes of the IPv4 address. Okay, so for this one, the second part is host part. Okay, so this is the part of the IPv4 address that you assign to each host. Okay, the host part uniquely identifies this machine on your network, and note that for each host on your network, the network part of the address is the same, but the host part must be different. Okay, so if you can see here, for the what we call for the network part and also for the host part, this is represent your computer. Okay, the network that you're using, and this is the host part, which is the devices that you use. Okay, so this part need to be different. Okay, so this one for all the computer inside your inside, let's say in one building, in your own office, maybe might be using this the same network part, but when it goes to the computer, different computer will have different number for host part. To make it much more clear, so I try to explain to you what is network and what is a host. For the network, it is a group or 2 or more hosts that connect using a common protocol language of communication. Today, most of the widespread method is using the Ethernet or Wi-Fi, and most popular one is through the IP lah. Okay, so at the host is anything that require connecting and communicating with other hosts over the network. A host can be computer, server, PC, network printer, smartphone, tablet, and even TVs and also fridges. Okay. So let's see the IPv4 address. So if you, as I mentioned previously, it has four numbers that separated by a dot. Okay, so the first group, and then second, third, and fourth. Okay, so each of this one represent 8 bits. Okay, so for each number, okay, and then when we combine all together, it's become 32 bits or 4 bytes. Okay. IPv6 is the latest version of the Internet Protocol, which it identifies device across the Internet so that it can be located. So every device that use the Internet is identified through its own IP address. Okay, so in order for the Internet communication to work. Okay, it is like a zip code, or what we call a street address, and also zip code for your for you to send the mail. Okay, so this is like the address to the computer. Okay, so for example, this computer or this device is connected to certain what we call to the internet. Okay, so the previous version IPv4 used 32-bit address scheme to support 4.3 billion devices. uh, Previously we thought it is enough because 4.3 billion is a lot, right? So but after the IoT come into the pictures, there are a lot of people using the laptop, people using the devices. All the devices is like exponentially increase. Okay, so this 4.3 billion is soon is not enough anymore for people to use. Okay. Fortunately, the Internet Engineering Task Force already recognized this problem going to happen. Like 25 years ago, they already know about what we call, they already predict this problem going to happen. So in 1998, they create the IPv6, which increased the number of the addresses by using 128-bit address. Okay, so this one can support around 340 trillion. Okay, so it is 2 with the power 128. Okay, so instead of the IPv6 address method of 4 set of 1 to 3 digit number, this IPv6 use 8 group of 4 hexadecimal digit separation by colons. Okay, so we are going to see the address, how the IPv6 address will look like. So we can say that IPv6 is a successor for the IPv4. Okay, so for the IPv4 is only have 32-bit value, but IPv6 address will have 128 bits. Therefore, the comparison in comparison, IPv6 will have enlarged address space. Okay. Now let us look into the address. Okay, so if you can see here, they have 8 space. Okay, for the IPv6 address. Okay, so the first 1 to 3 address is called prefix. Second, the fourth one is subnet ID, and the another 4 is interface ID. Okay, so let's see the example. Okay, so you're going to see not only number, it is called hexadecimal because it's a combination of number and also what we call the alphabetical inside here. Okay, so let's say the first one, 1 to 3 will be the prefix, which is it describe the public topology that is usually allocated to your site by ISP or regional internet registry, because every area will have their own regional internet registry. For example, in Malaysia, so they are considered is one what we call one regional. Okay, so it's become a country or state. Okay, so this one um, uh, will have the site prefix. Okay, so the second one is um, which is sub ID, or what we call as subnet ID. Okay, so this one uh, we can consider it another like administrator to allocation for your site. Okay, so the subnet ID describe the private topology, also known as the site topology. For example, if let's say previously it is Malaysia or in KL, now it goes deeper, area and road numbers for your address. Okay, and 5 to 8 is the interface ID, which is the exact address. Okay, so we can consider it's like the number of the unit or something like that if you want to compare to the real address of our house lah. Okay, so the rightmost 4 field 64-bit contain the interface ID, also referred to as a token. Okay, so the interface ID is either automatically configured for the interface MAC address or manually configured in EUI64 format. Okay, so meaning that this is for the devices, for exact location for the devices that we use. Okay, so it give the address through the automatic configuration. Okay, we look again. So the first 3 number that with the 2 dot separation. Okay, so this is a site prefix. Okay, so this one is representing the public topology, and then subnet ID, the number 4 is representing the private topology for the site, and interface ID contain the interface ID of each devices that connected. Okay, so let's see the differences between the IPv4 and the IPv6. Okay, so this is just to recap, to put it together so that it will be easier for you to understand. Okay, so as we know, IPv4 is deployed earlier, which is in 1981, and IPv6 is in 1998. And then IPv4 is using 32-bit IP address, which we have 4 number that is what we call separated by a dot, and then IPv6 using 128-bit IP address, which 8 numbers or a what we call alphanumerical hexadecimal notation form, separated by double dot. Okay, so for each of the address, and then IPv4 only capable of what we call give you the address for 4.3 billion addresses only. Okay, so this one, if let's say you want to reuse it, you have to mask the address again so that it can be reused. Okay, and then for the IPv6, it can provide 7.9 times 10 but with the power of 28 address. Okay, so every device can have their unique address without having to mask it again for reuse. Okay, so then IPv6 numeric dot decimal notation, like I mentioned. So the all of the address is in the form of numbers, and then it is separated by a dot. For the IPv6 is using alphanumerical hexadecimal notation, where it is a combination of number and alphabet, and then it is separated by 2 dot for each of the numbers or each of the address. Okay, but in the same time, it also have the simplified version. Okay, so we don't have to look into that one lah. Okay, so and then it can, for the IPv6, whether it can use DHCP or manual configuration, but for IPv6 it can support the auto configuration for the address. Put here the video. You can look into this video for better understanding. With that, thank you very much for listening. Inshallah, we were going to continue with the next lecture. Thank you very much. Assalamualaikum.